Hello, 8th graders. Just a quick review of the periodic table and the Lewis dot diagram process in preparation for your quiz. A quick check. What you'll need to know for the quiz is the name of the different groups. So by name, group number 1 is the alkali metals. Group number 2 is the alkaline metals. Group number 3 is the transition metals, and that includes all these and all these. These are named by their first element in the group. So you have the boron group, the carbon group, the nitrogen group, the oxygen group. And then the fluorine is a different name. It's called the halogens, halogen group. And lastly, the noble gases. So you need to know them. If I were to ask you one of those, you'd have to tell me the name. If you're looking at the periodic table, you should notice right away, since many of them are named metals, most of the periodic table is made up of metals. Anything to the left of this little zigzag line are metals. Anything to the right are non-metals. One exception to that is hydrogen hangs out over here under the group number 1 because it does have 1 valence shell electrons. Which brings us to the valence shells. How do we determine how many valence shells or how many electrons in the outermost energy level each element has? And it's quite simple, actually. Group number 1 has 1 valence shell. So if you were to draw this, you would see that on the outermost energy level, all of these elements have 1 electron on their outermost shell, or what's called the valence shell. Group number 2 has 2. And then we skip these. All the transition metals we skip. It doesn't follow the same rule. We skip on to group number 13, the boron group. Those all have 3. Carbon group all have 4 valence shell electrons. Nitrogen has 5, oxygen has 6, fluorine has 7, and the noble gases, the fluorine is not the fluorine group, it's the halogen groups, has 7, and the noble gases have 8. When we're talking about valence shells, the valence shell is considered full when it has 8. So these are called noble gases because they have a full outer valence shell, and they don't tend to bond with anything. If I were to ask you, point to a different element on the periodic table and say, is this a metal or a non-metal? Is it a solid, liquid, or gas? You would be able to do that quite easily. The next thing is to determine how many elements will bond with certain elements. You have to look at the valence shell. So if I were to look at 8, how many would bond with noble gas elements? Well, none really, because they have a full outer shell, and therefore they're full and they don't bond with anything. That's why they're called nobles. They don't bond with anything else. The halogens bond with things because they have 7, so they have 1 spot. Okay, if they have 7 valence shell electrons, that means they have 1 spot available to bond with, and they want to be full, so they want to bond with something that to have that outer valence shell electrons full with 8. So it has 7, it wants to bond with 1, has 1 spot to bond. Where oxygen has 2 available because 6 is 2 less than 8. So in order for it to be full, it wants to bond with 2 areas on that atom. And nitrogen is in group 15, which has 5 valence shell electrons, so it wants to bond in 3 different locations. So if I were to look at that on a dot diagram, and we'll look at nitrogen, for example. If I do the dot diagram for nitrogen, nitrogen is in group 15, so it means it has 5 valence shell electrons. So I would draw the dot diagram like this: 1, 2, 3, 4, and 5. And you should notice right away that it can bond where there are not pairs. So it can bond right there, it can bond there, and it can bond there. So it can bond in 3 different areas on that atom in order for it to have 8 valence shell electrons. If I'm looking at, let's say, nitrogen, we just did nitrogen. Oxygen has 6 valence shell electrons. So if I were to draw oxygen, it would look something like this: 1, 2, 3, 4, 5, 6. And notice right away that oxygen has 2 places where it can bond in order for it to fulfill that 8 outer valence shell electron, or the octet rule. So that one wants to bond with 2. So let's talk about now if an atom does fill its outer energy level, that like oxygen filled its outer energy level, and it added 2 electrons in order to do that, or it bonded, what would the charge be of this bond? If it gained 2 electrons, electrons are negative, right? So if it gained 2 electrons, that became more negative, and it would have a charge of -2. Okay, this one gained 3 electrons, so it would have a charge of -3. Whereas if you're looking at something on the other side, these alkalis tend to lose an electron because their outer energy level only has 1 valence shell. Now let's look at sodium, for example. Sodium. Okay, right now it has 1 valence shell. If it gets rid of that, which gets rid of the electron, it becomes positive because getting rid of negative things makes it a positive atom. So you need to know that as well. So again, go over the names, know what are metals and nonmetals, know what are solid liquids and gases, and lastly, how to draw a dot diagram and how many valence shell electrons are found in each group. So review this video. If you have questions, please ask, and you should do really well on the quiz. Have a great day.